I'm Daniel, my colleague Shakti, and we're going to talk to you today about search at LinkedIn. And just to start us off, I know this is a Silicon Valley crowd, but maybe how many folks here use LinkedIn, have profiles? Pretty big crowd. In the United States, we have a pretty nice penetration. There are actually over 200 million people in the world. The question is, why? I'm not going to try to survey folks here, but I think that there's a really clear reason for people to use LinkedIn. And it's other people. For those of you who didn't see Soylent Green, I'm sorry.
You're still using this slide. I'm old enough to watch that movie.
Well, and by the way, it is really true, of course, that as we converge on having all the world on LinkedIn, the demographics are getting to be converging on true norm. But second order joke there. Now, search in particular is fulfilling for us the most important value proposition for a network like LinkedIn, which is to allow people to find and be found. So you can see here, and on the left, a typical, we're always looking for people who know how to do other technologies. First time of many, I'll say we're hiring. But also, one of the things is that, all of you are on LinkedIn, you're probably not looking for people all the time. One of the reasons you're there is to be found. In fact, some people get pro accounts just so that they get more of this kind of vanity / professional value to knowing who is finding them, why they're being found, what keywords with what frequency. And for those of you who don't have sort of the premium access to see this, it's everything from keywords to volume. But this is a major use case for LinkedIn. So search matters. But beyond that, to address the question as to, isn't it just about entering names? It's not just names. In fact, it's not even just people. Right? So if you look for a search for data mining, you see people who know data mining. You see data mining jobs. You see discussion groups that are about data mining. And there are millions of these, and this is just one example of how LinkedIn is serving as a hub of professional content. So again, search is often this gateway to discovery. Now, one of the unusual things about a search engine where you've got all these people who are using it, but people are also the corpus in many cases, because people search is still a major application for us, and in any case, almost all of our content is associated with people, is that every search is personalized. And I don't mean personalized in the sense that, we're going to slightly skew the query based on an analysis of your log history, or maybe try to do a little bit of collaborative filtering. I mean radically personalized. So here, what you can see on one side, and on your left, is my profile with my beautiful daughter. And you see what happens when I search for architects. Now, to me, an architect, of course, is a software architect, a solutions architect. In any case, somebody who, let's just say, hopefully at one point in his or her life was a software engineer and now gets to use the word architect. My wife, on the other hand, works in real estate. For her, an architect is someone who actually is involved in building real things, sort of things that if they break, you can sue them, as opposed to just file a JIRA ticket. For her, an architect is somebody who works with houses. Now, you could say, well, this is a word sense disambiguation problem. And you could approach it that way. But one of the things with LinkedIn is that because we incorporate factors like who is in your network, what industry are you in, factors that we actually know explicitly about you, we're able to return results that make sense personally. And indeed, you can see that my results and her results for a query like architect are radically different. And this is important because searching on LinkedIn is very different than, say, searching in a catalog of documents, or even in the sense of searching on the web. The ways in which people are using our content reflect typically some kind of personal connection to it. They're a lot about you.
Is there any reason that the recall set is the same, the number?
That's a good question. I'll repeat it. So is there a reason that the set is the same? When you do a query that is a text query, you're typically then have full recall against the collection, which is, so we are in fact having access to the same set. That's not true for all queries. In fact, if you try and do a query where you don't like just an empty search, if you will, you'll find that you're restricted to a subset of the collection, essentially first, second degree, and group members. Also, you can use network distance as a facet, and first degree for you, for example, is very different than first degree for me. But here, because I just wanted to show off differences in ranking, I did the query identical. Now, there's a lot we can talk about how LinkedIn works. One of the nice things about LinkedIn is that we've published a lot of this. We have a lot of our material is open source. We blog about it. We even show up in the press from time to time. But I thought for this audience, we picked 3 topics. I'll talk about the first 2, query understanding and search spam. Shakti is going to talk about unified search, which just launched. And we'll use the Q&A to go in sort of a deeper dive about any questions that people might be interested in. So let's start with query understanding. Anyone recognize the reference? Not so on the green this time. Hitchhiker's Guide? Douglas Adams, anyone? Philosophers going on strike in the Hitchhiker's Guide because they're protesting that a machine is going to answer all of their questions for them. They say, we demand rigidly defined areas of doubt and uncertainty. Personally, I'm a fan of people being involved in the process of query understanding. But of course, machines have to do their job as well, regardless of whether the Amalgamated Union of Philosophers go on strike. Now, a lot of our queries are not first name, last name. People can enter company names. They can enter job titles. They can enter locations. Any sorts of entities that can show up. So the question is, what do we do when we get these queries? One of the nice things about LinkedIn that doesn't hold true of, say, the broader web is that we traffic in semi-structured data. We have entities everywhere, right? Our members are entities who have profiles, and those are filled with a variety of structured content that they've selected from controlled vocabularies, fielded data that they fill in that's typically short, and then full text descriptions. Companies themselves are objects that have all sorts of metadata, universities and so forth. This puts us in a particularly good position to look when somebody enters a query of how we're going to tag it and figure out what parts correspond to what kinds of entities. As you can see, there's a pipeline. If you look here on the right, when we get a query, our first step is to segment it, to be looking at first at a token level and then at multiple tokens, phrases that we're going to associate with the different kinds of entities. But then we have a next step where we're tagging the entities by their various types. There are a variety of ways that you can do this. Ours is using a hidden markup model. And as a result, when we're getting a query, say like LinkedIn CEO, we're able to realize LinkedIn is a company, CEO is a title. Other queries can perhaps be more complicated. There can be multiple competing interpretations with different probabilities, but the net result of this is that we come out with a structured object that we can work with, and as a result, we're then able to use that for matching. What's important to note is that you could have said in the previous example, well, obviously LinkedIn is a company, what else would it be? Obviously CEO is a job title, what else would it be? Although actually I'd be cautious there. A lot of things that look like job titles in one language look like first names in other languages. I think I've seen people with Seo as a first name. So word sense is contextual. As you see in the example here, if I look for Bob Mayo, we end up with, Bob of course can expand to similar first names, Robert Mayo, Bob Mayo. We recognize here that first name, last name is the most likely interpretation, and we favor those matches. But then I look for Mayo Clinic, and there, when we segment that query, we realize actually that makes more sense to see that it has the name of an institution, and the matches here are ones for that. In fact, we use what we call a hero slide at the very top, saying actually, perhaps even the institution itself. But the matches are ones that are capturing that there. You could use other techniques here. You might have imagined, well, we could have just said favor things that match the phrase, but it's useful to capture as much structure as we can in the process of understanding the query, because that frees us up to use that sort of meaning to do further processing later. And actually, we want to understand queries as early as possible. I think at this point, people have gotten familiar with various means of query suggestion or type ahead or various interfaces where, as you're entering characters, we're capturing that. What we want to do is, it's not just a question of saving you time as you enter a query. We'd like to have a query that is ideally unambiguous, right? A query that, if you actually think it's the right thing to ask, then we are also in a position to answer that. So a big advantage of these sorts of type ahead interfaces is that they drive the user towards a region of the space that we understand. And in fact, we put as much effort now in our type ahead as into many other aspects of our relevance. But I just really want to emphasize the importance of working with query structure, especially for folks who aren't necessarily sort of familiar with working with this kind of semi-structured data. The easiest thing to do is to say, well, we'll find the results that match the query interpretation, and we'll boost them. We can even be more aggressive and filter them, but that's that's an interesting philosophical conversation we can have after some more beer. But we can do more than that. There's a lot that you don't necessarily see going on. When we analyze our logs, we can bucket them by the query classes, by the way we've segmented them. And that's extremely valuable for understanding different classes of users, different classes of information needs, different behaviors within different sorts of queries. We can also do query rewriting in a way that's specific to query classes, so that if we think that Bob should be Robert, that makes sense as a first name, but it doesn't make sense if it occurs somewhere in a different field or with a different intent. And I think this is, there's a big difference between focusing entirely on clicks and on, say, top-ranked documents versus this notion of, did you understand the query? Did you get the right set of results? One of the things that happens with query understanding is you're basically saying, did I understand the meaning of the query to figure out the things that match it? So this may bring folks back, I think, almost to the 1980s. But for folks who are, read, say, classic books on information retrieval, you think of precision and recall in terms of sets, rather than the more modern thoughts, which typically people, especially trained on web search engines, that you think in terms of average precision, precision at 1 being more than 2, 3, 4, and you can sort of do the typical formulation there. That's great, and actually it's very important to think of relevance in a user-perceived way in terms of what they'll see. But in terms of query understanding, you actually do have to think about the set of results that are going to match your query interpretation. And then also, it's not just about what answers users end up seeing, but what questions users end up asking. Because query understanding is really more of a process of going from what's in the user's head to the best expression of it. And that's why things like type ahead become so important. Before I go on, any questions on this section?
So when you're trying to classify, understand a query and classify it into a class, for example, right? There's always a total come with certain weight and probability. It's not 0, 1 anyway. So whenever you do such meta-analysis on top of that, like the bucket and search analysis and all of that, how do you do that? Do you do a weighted average, or would you just kind of say anything about certain weight and take that and look at that bucket?
I'll repeat the question first, which is that, after all, this is a probabilistic process for doing query understanding. How are we going to do bucketing when we only know with certain probability that we understood it? So there are a variety of ways. The simplest, to be quite honest, is to threshold, because, or to take the most likely, because we're talking about aggregate analysis. We can be a bit smarter about that, but bear in mind, the typical thing we're trying to do here is make sure that we're segmenting our analysis of user behavior. So as long as our threshold is reasonable and we're not systematically introducing some skewed set of things, we'll be okay. One of the ways we can assure ourselves of that is by human review. So a lot of, this is maybe a broader point. Whenever we talk about metrics that involve precision, we ultimately need to involve humans, because it's very hard to get completely robust proxies from any other sorts of data. Good questions?
How many classes did you have, and how did you come up with paid classes?
So I use the word query classes here perhaps a bit deliberately vaguely, but the way to think about this is that we are tagging at the token level. So you could say that basically we have the set of query classes is in principle just the the number of token tags to the power of the maximum query length. Of course, that would get absurd. So that's how you end up with classes like name searches, company and title, first name and company. One of the things is that we see what kinds of queries people do. We can also see when there are queries we think they should do but aren't, what's going on there. But we focus on classes of queries represented, if you will, in terms of the kinds of tokens with some flexibility as corresponding to some meaning. So for example, when you're looking for people with a given job title or company and title, it's clear what that means, and it's also clear from the tags. And then you're sort of being reasonable. But title and company is the same as company and title. But there's some nuance. Just to drill on that one for a moment, there's a difference between looking for LinkedIn CEO and LinkedIn software engineer. There's one CEO, there are more than a handful of software engineers. So, but
to explore running any unsupervised clustering algorithm and coming up with classes and then doing some kind of classification to.
We can. I mean, I think I'm nothing against unsupervised clustering. It has a lot of applications. In this case, we know a lot about the data, so we start off with what it is we know. We do use a bunch of machine learning in various places. In fact, we'll get to that in the next section. But before we sort of leave everything to an unsupervised approach to try to make the best of the signals out there, we're able to do quite a lot with with labeled clusters corresponding to the labeled signals coming in. I think it's interesting when we don't understand some set of queries to then appeal to approaches like clustering to show us, oh wow, there's some feature here is bimodal, what's going on, or there are these clusters. Now, often that's really exploratory analysis. We do that often with looking at behavior more generally, like user behavior, say within a class, as opposed to just trying to identify the classes of queries themselves, say at a session level or something. will go on to the next topic. The next topic is spam, or the evolution thereof. And I guess I should warn Brian that now it seems like I'm taking it. You know, so your current title involves spam and what?
Yeah, we had a small small reorg 2 weeks ago, and I'm in charge of search spam now too.
Okay, but removing it, right? Not encouraging.
Removing it.
Okay,
Yes.
we're on the same side. That's great. That's great.
Yeah, I'll generate it. I'll send it to you.
But for those not in the joke, Brian used to be a head of query understanding, and I swear I did not deliberately steal your title, but I'm happy to own it now, following in good footsteps here. So let's talk a bit about search spam, and let's look at a search spammer. This is a real user. The real user has slightly. I've tried to gray out the face to protect the perhaps not so innocent. But here on your laptops, you can probably follow along. It's the beauty of having a public profile. So let's start with looking at the summary that, let's just call this person Mr. Spammer, puts on his profile. It's verbose. Really, this is just advice. If your profile looks like this, it's not particularly good for getting a job through LinkedIn. But it's not abusive. It's legitimate enough. This is not something we would simply take down on the basis of it. But then, yeah, he does sales. Clearly, at this point, you've crossed the line from being a questionable writer to being someone who's actually clearly trying to game our system. Yep. Yeah.
What's the intent of a spammer creating a fake profile? What are they trying to accomplish?
So the question is, what is the intention of a spammer creating a fake profile? This isn't a fake profile. This is a real user who has added a bunch of extra keywords. This is SEO, really. There are people who create actual fake profiles for humor, vandalism. For a little while, there was somebody who was making himself the CEO of Yahoo as a sort of political statement, if you will. But actually, one of the interesting things, I think to your point, is there isn't actually the sort of payoff for being an outright spammer on LinkedIn that you might have for being a spammer that's trying to attract general web traffic. I mean, there's limited value from having an ad. It's really, we haven't allowed people to include malware on their profiles, that sort of thing. In fact, one of the most dangerous kinds of spam is not involving LinkedIn at all, but people trying to fake LinkedIn messages in order to get people's attention. With that said, there are reasons you might try to gain our ranking. I mean, people do search for sales on LinkedIn. And so keyword stuffing is kind of a tried and true technique for hitting things like TF-IDF. And this is a particularly unsophisticated attempt to do so. But there are a variety of things people can try to do, some of which are more pernicious than others. So, to that point, actually, we treated this as a machine learning problem. And how can we find the spammers? Now, I mentioned earlier that all of our queries are personalized. This actually has some advantages for us, because diversity turns out to be one of the biggest defenses you have against spammers. It's actually a good defense against kind of bad people in general. One of the criticisms of having, say, one dominant operating system or one dominant browser is that it creates a vulnerability that hits everyone in the same way. But if everybody does things differently, it's hard to shotgun in quite the same approach. Now, so for example, we need to worry about people trying to SEO first name, last name queries. So, perhaps sure Barack Obama, Bill Gates, that sort of thing. But aside from the truly celebrity folks, the queries that are being targeted are non-name queries. job titles, skills. I mean, it's all about the payoff. Those are the places where people want to show up and they feel like they have some chance. But we can then look to see what are the top unpersonalized results. And this is a fiction because all results are personalized. You can think of it conceptually as the average you would get looking overall at users. In practice, it means we simply turn our features that reflect the member off when we do this, which is a reasonable proxy. So we've taken the 10,000 most popular non-named queries. We're showing the, now we're grabbing what are the top results that a non-personalized user would see. Now, this is about training. For those of you who work in machine learning, the biggest challenge often is collecting training data. Well, we're crowdsourcing this. Now, we had to make one concession because of our concerns about member privacy, which is that although LinkedIn encourages very public profiles, some of them are private, and we had to remove those from consideration. But that's, fortunately, spammers tend to like being public. That's the whole point of being, gaming the system is getting attention. And now we had a set of profiles that we could label. And there, we worked with Crowdflower, which is a wrapper around a variety of ways of getting training data through, essentially microtasks. Essentially, think of Mechanical Turk, if you're not familiar with the specific vendors there, to get, is this spammy or not, with some instructions there. There's an interesting thing about spam. What's relevant to you might not be relevant to me. I mean, you take the example before of architects, and I think if my wife saw the results that I see for architect, she would say, LinkedIn is broken, I'm going to go back to, or whatever it is you go back to. But the, right? You'd use another professional network to exist. But the, so it's not possible for us to say, oh, I know that these are the most relevant results for you as a crowdsourcing task. That simply won't work. However, spam, pretty objective. You can actually use crowdsourcing to label things as, not just as spam, by the way, but as just bad results, implausible results. I wrote a blog post at one point called WTF at K as the measure that to propose here. And that's not some World Trade Federation. Egregiously wrong results are things you can crowdsource for evaluation, and spam unfortunately falls in that category. And then, train the model. And we're essentially doing probability of spam. And now, as we start identifying spammers, the strategy is going to be demoting them. Spammers, by the way, we're still not treating as kind of evil criminals. Okay, people try to use LinkedIn in a way that hurts members directly. That's fraud, that's abuse, that's your account is canceled and we call the police sort of thing. But here, these are people that are just kind of being, gaming the search engine, and we don't want them to succeed. And there, we're basically computing a probability of spamminess and making a trade-off between trying to capture all the spammers versus making sure that we don't have false positives. And this is a threshold again. Yes?
So Daniel, usually spam or fraud detection is like a very unbalanced class problem. Can you elaborate on how you kind of address that?
Sure. So the question is, given that spam or fraud detection is an unbalanced problem, how do we identify that? So the good news here is that we could identify sets of people who seem mildly spamming, and then get a class of people from there. Because I'm one of the rare cases where I can't talk about internals as the features we're using to identify spammers, let me use a different example to illustrate the same point. There are people on LinkedIn who very aggressively network. As we call them lions. they're actually reasonable people, but it's useful sometimes to identify them. However, they have large numbers of connections. I personally have over 3,000 connections. If you were just using a threshold based on number of connections, I might be identified as a lion, even though you actually, if you look, you'd see that my behavior, I'm not just connecting to everyone in sight. I don't, there are other characteristics of people who are sort of openly networking this way. Lions are a small class, so they exhibit exactly this problem. But you can imagine perhaps already the way in which you address this, which is that if you look at the subset of people with a large number of connections, it's easy to construct a balanced class. In fact, you can tune that by observation. It's the same here. Our features, if we trusted our features in some simple rule-based way to grab all the spammers, well, no problem, we'd be able to just do this trivially. But instead, we're able to get a set of folks that is large enough. There's a risk of recall there, for sure. You're never 100% sure about recall. The only way you can handle that is to take, you've carved out the set where you think your minority is. Well, if you're missing huge number of them in the remaining set, hopefully you can detect that, or you can sample from that. If they really can't find them, they're not that big a problem. At least, and remember, these aren't people who are trying to take the site down. We can afford to miss a few. It's not the end of the world. This is really more about emotion. And in fact, this is how we use it. We end up with a probability score. And remember, most people aren't spammy. And so if you don't seem to be spammy, we just want you to not know this ever existed. Once you hit some threshold, we treat you as just like, basically, you're going to show up in the results at the very bottom. You'll be found by your name, but it's about the only way. And in the middle, well, we handle this linearly. You can imagine other smoothing functions, but we end up having something that fits very well. And then we can, because our approach is essentially think of it as multiplicative or additive and a log-based factor for combining signals, this works quite well for us. So, I mean, yeah, I threw in a little bit of code here to perhaps make it slightly more technical, but it's this is how you would expect an integrated independent factor into other parts of a relevance function.
So you just argued that spammer for some people could be not spammer for others. So this is audience dependent.
No, hold on a second. I don't mean to say that spam for some is not spammy for others. I actually believe that spamminess is as close to objective as you want. Relevance for some is not the same as for others. In other words, I would expect that you and I who do the same search should get different, we should have different utility functions for what is most relevant, but very similar utility functions for what is spam. Is that okay? Now, spam is an arms race, which is why I can't reveal specific features there, because spammers will work around them. Of course, spammers will try to work around them anyway. Bear in mind, the best feedback for a spammer is how much attention they get. But we do have some defense against spam, which is that you can't really spam everyone all the time on a site which is using features like network proximity and homophily. I mean, you're going to be kind of stuck spamming segments or you're doing the best you can relative to the features that aren't personalized. The other thing is that the nice thing about an arms race of this kind is that if the spammers are doing a lot of work to discover new techniques, if they're successful, we'll discover them too. And they put in a lot of work, which overnight we'll be able to fix. So I actually believe that in this case, the arms race is not necessarily to our disadvantage, because remember, here I'm kind of channeling Matt Cutts, we don't have to eradicate the possibility of being a spammer. We just have to make it not worth the spammer's while.
Daniel?
Yes?
If people's profiles will show up through Google anyway, does that kind of reward the spammer, not within LinkedIn, but externally? So that sales guy, if you look for sales manager, will Google not have seen that page at some
So
point?
the question is, hey, even if they spam, even if we stop them from showing up on LinkedIn, won't they show up on Google? So I don't know how often you guys do vanity searches. I'm not going to do show of hands, but I'm guessing for many, there we go. For many of you, whether you search for yourself on Pleco, Google, or any other search engine, that your LinkedIn profile probably shows up, I'm going to say top 3 unless your name is particularly common, in which case it's probably somebody else's LinkedIn profile with the same name, or perhaps a celebrity. That's cool. That's not what we're worried about. We're worried about things like you're going to look up sales manager, or I guess in your case it's professional services director. That's actually really, there are a few things there. One, actually those people who are looking for those, they look on LinkedIn more than they look on Google. Because now, it's true that in theory, you might say, well, I'm just going to don't think from the spammer's perspective, think from the searcher's perspective. Somebody looking for these people. You go onto Google and you get a very unpersonalized experience. That might be okay when you're looking for somebody with a unique name, something I'm familiar with having, but it's not all that great when you'd like to find people you have a chance of getting to or get the benefits there. So again, the payoff for the spammer is much lower.
Can we use document features like shared timeline? Because if let's say somebody is spamming for a title like sales manager, they will have employer or something. You can see what is the similarity between the sections where people share some timeline. I'm curious why you're not using any document level features or the timeline features to identify spam.
So the question is whether we're using document level features to identify spam or not. I don't believe I said that we weren't. I deliberately am not enumerating the features, but I think you can, and I will openly admit that we look for keyword stuffing, but that's obvious. We do look for other more sophisticated document level features. One of the nice things is that once we had a collection of spammers, made for some very nice abilities to analyze and codify the things people were doing. Bootstrap, what we already recognize. A lot of spammers use multiple techniques. They're very educational to look at some spam. So, in that case, I'm going to hand this over to Shakti. I'm going to talk about unified search.
Thanks, Daniel. So yeah, this is, I guess you got the reference to Lord of the Rings. Let's talk about unified search. This is a new functionality that we have been rolling out for over the last few days. Some of you might have seen the press around it. We'd like to think of unified search as one search to rule them out. And I'll talk more about the motivations as we go on. But first, let's look at what we have in the ununified search world. I think we already coined the ununified search term a while ago. To search on LinkedIn, as most people see today, you have to start with selecting the content type you're looking for from a drop-down, followed by a search. We believe LinkedIn has a lot of valuable content outside of people profiles, and hiding it behind a drop-down makes it less discoverable. In fact, a lot of our users don't realize that in addition to being a great place to find people, LinkedIn is also a great place to find jobs that are fit for you, find group discussions in areas of your interest, find and research companies, and much more. And that is the problem that we're trying to solve with unified search. The goal for unified search is to make all of LinkedIn content discoverable. We are starting towards this through 3 new features that we are launching right now. They are query autocomplete, content type suggestions, and the unified search result page. So the typewriter has been a big part of the LinkedIn search experience for a while now. In fact, we open sourced Clio, which is the technology we use to power our personalized network-aware type-ahead last year. But in general, our focus for the typewriter has been more towards what we call instant results. That is showing profiles, companies, and other information as you type, which will lead you directly to the landing page, lead you directly to the group you're looking for or the person you're looking for. And that works quite well for known item searches when you know what you're looking for by name. For example, if I'm trying to find Jeff, instant results in type ahead works great. But that is a problem. It doesn't work too well for broader query intents, for more exploratory searches. If I'm trying to find jobs that are a good fit for me as a Java engineer, type ahead is not going to work. It's not going to match something by name. If I'm trying to find people that we can hire who are great Java engineers, again, type ahead is not going to work for that. When we look at the problem of query completion, we have to take a few things into account. The first is, it might seem very natural for us to suggest autocomplete queries to what might be the most popular query. In fact, query popularity is a great flyer towards query intent. But the problem that we see when we take that approach is that going purely for popularity tends to skew or tends to suggest or lead the users to queries that are very, very generic. And in fact, a lot of these very generic queries do not have enough information within them to lead to useful results. This problem is further aggravated for LinkedIn because the query distribution we have for search is very heavy on tail queries. So significant fraction of rare queries and a small set of top rare queries. So the goal is for us to lead the user to a query that is most likely to result in a successful search and not just the most popular search. And then this is a balancing act. We have to, going towards popularity will ensure that we suggest a completion that most or more users will accept. Going towards other factors, going towards the relevance of the searches that the users are likely to see when they execute the query, is going to lead users down a path of more likely satisfying the information need that they came in there. And then, yeah, of course, you have to balance this and look at the overall picture. The next step in the query elaboration process for unified search is content type suggestions. In unified search, we do not require the user to actually specify the type of content they're looking for. And that's something I'll talk about right after this. But keeping that in mind, there is value to inferring the right content type for the query and the user as early as possible in the process. In fact, we want to provide the user the opportunity to narrow down the search they are doing right at the query formulation process and give them the opportunity to steer the direction of search to the content type they're looking for. So what we see here happening here is, if someone is typing the query software E, autocomplete kicks in, completes to what we think is the best suggestion with the software engineer in this case. And then for the query software engineer, we determine that in this case, finding jobs is the most likely use case, which is followed by finding people for software engineers. Now, as with autocomplete, content type suggestions are trained on searches that have been successful. So again, it's the same trade-off between popularity and the likelihood of having a successful search. Specifically in this case, we train on data that is we train on user behavior data that has been collected on pre-unified search. When users select a drop-down, input a query, go on to do a search and take action on the results, we analyze that data and build the models on top of that. That presents one problem. The drop-down, as I mentioned, makes it difficult to discover the non-standard or the non-default content type. And except for people, so jobs, companies, groups, other verticals, they are at a disadvantage here. They have a findability issue. So we do need to correct for the findability bias and give other verticals a chance in this bootstrap phase. The good thing is Unified Search is live, is working for some, is rolled out to some users, and now we are getting data on how our users are either working with the content type we are suggesting or switching out to a different content type and correcting their searches. And that data is much better, much higher quality data that we are integrating into the models as a sort of a constructive negative feedback.
Have you ever considered using some kind of explore exploit thing to defeat the findability bias? Like
Okay, so the question is, have we considered using explore exploit to defeat the findability bias? The answer is yes. There is value in using explore exploit, and even though I cannot go into too many details specifically of what we're doing here, but we also need to keep in mind that explore exploit techniques are most useful in cases where you have rapidly changing scenarios, rapidly changing intents and models. For content type suggestions for queries, we have a reasonably stable distribution. If someone is searching for software engineers, or if someone is searching for LinkedIn CEO and finding people that match, it's unlikely that that query will start becoming more of other vertical or other content type query in the future. So explore exploit is useful, but we do not necessarily need a real-time self-correcting system for this use case.
Also, just in case it wasn't clear, this is correcting the bias in past data, which we can't retroactively expose.
Yeah.
When this becomes full 100%, how will you get any idea of what was the content type? Let's say new content type.
So I'll talk about that when we can get to the next section, but actually when we go to full 100%, the data that we will collect will be much better than the data that we are bootstrapping from. The bootstrapping data has a findability bias because it is affected by users not selecting a dropdown, not knowing that there is other content available on LinkedIn. When we go to 100%, there are other ways users can provide feedback about a vertical being right or wrong. Specifically, the strongest signal we have is we have a left rail where users can change the vertical explicitly. In addition, we'll talk about a more diverse search result page where they can provide signals. So the biggest change that we are bringing through Unified Search is eliminating the drop-down for selecting the content type to target. Instead, what we do is we try to determine what is the most relevant content type or content types for the query and present a more diverse and unified search result set. What we see happening here is the user is searching for CAD, and we are showing a jobs primary. So these are jobs that are for computer-aided design. And then you can see that we have a small set of results from people search on the same page. That is what we call a secondary cluster.